Sie ist auf die andere Seite. Sie steht gerade. Hallo. Okay, du kannst ja.
Das fängt ja nicht so hier 4 Jahre vor der Pensionierung. Das war Nachtzug nach Stockholm. Also der erste, was es vielleicht eigentlich erst mal rübergekauft. Das könnte ja doch ganz gut sein, dass der Schritt eben
interest in inaugural lecture, and I will now hand over directly to our president, Professor Saidi.
Yeah, dear guest, dear Dean Yosvik, and of course welcome Professor Saidi Saidi. These lectures are always a very special occasion for us because, and many of you have heard me say this in German, and now I get the chance to say this in English, because they are a special event for an academic scholar, and I think we all can remember the times that we have had this event and were able to present ourselves to the academic community, to the university community. And it's a chance to formally and officially welcome you, Professor Saidi, to our university community. You joined us as a W3 Professor of Computer Engineering a while ago, actually. I turned on the music. Sorry. Oh, really? Sorry, I shouldn't be done. I do this like this. But I'm looking forward to a talk that's joined by music because we haven't had that before. So this is wonderful. And your lecture tonight, as we see here, is called Designing Thinking Machines Reasoning in the Area of Physical AI. And it asks us to picture a future in which machines do more than compute. And if you look at this line, we can already imagine that this. About more than efficiency. It has been about also understanding ourselves and the systems we create. And as artificial intelligence becomes part of the physical world, and we all feel it every day, your research reminds us that intelligence must be not only powerful, but it must be safe, trustworthy for almost, and aligned with human values. That is quite a task, as we know. It is deeply technical, yes, but also profoundly necessary. And you bring with your work to it more than a decade of expertise in hardware and software design for safety-critical systems. You move, it seems, with ease between formal methods and practical engineering, between theory and application, showing us that the bridge between the two is where true innovations happen. Here at TU Braunschweig, we take pride in scholars who not only invent new technologies, but also ask what those technologies mean. And your work does exactly that. You combine computer engineering with insights from philosophy and sociology, opening a dialogue between disciplines that might once have spoken different languages. And that, I believe, is the spirit that makes our university truly proud. We have collaborated with leading partners from Airbus, Bosch to BMW, but what stands out most is the purpose that guides you. You make technology that serves people. Whether through assistive systems for the visual impaired, or through frameworks of collaborative decision-making among autonomous machines. Your research aims to make our digital future more inclusive, more transparent, and more human. And it could hardly be more timely. The region, or this region of Germany, and indeed almost all of Europe, has long been famous for its engineering excellence and its mobility. For more than a century, innovation here was defined by precision of the gasoline engine and the human hand behind the wheel. But we all know the world is changing. We see new players, new markets, moving with astonishing speed, shaping the age of electric and autonomous mobility. And in this transformation, your research is nothing less than essential. And we are all looking forward to your talk to learn more about this breathtaking work. And with this, I hand back over to you.
So, dear President Professor Itel, dear Professor Saidi, dear Selma, dear colleagues, dear students, and dear It's my great pleasure to welcome you all as the Dean of the Faculty of Electrical Engineering, Information Technology, Physics to the inaugural lecture of Professor Selma Saidi, newly appointed Professor of Computer Engineering here at our faculty at Technische Universität Braunschweig. Professor Saidi's career is an excellent example of the path of a truly European researcher. She studied in Algiers, earned her PhD at the University of Grenoble at the prestigious Verimat Laboratory, founded by Turing Award laureate Joseph Sivakis, and she began setting new standards in the design of hardware, software co-design and system safety, laying the groundwork for what today are key enablers of safe, autonomous and cyber-physical systems. After completing her doctorate, Professor Saidi joined TU Braunschweig, where she led the research group at the Institute of Computer and Network Engineering under Professor Rolf Ernst, contributing to several EFG, EU and BNBF projects on real-time multi-core systems and mixed criticality platforms. Later, at TU Dortmund, she built her own research group as Professor of Embedded Systems, successfully acquiring over 1.5 million euro in competitive funding. Her projects span from contract-based quality of service assurance in distributed systems with Bosch to safe and guaranteed services for 6G communication networks and many core architectures for avionics in collaboration with Airbus and Embraer. Beyond research, she is an active community leader, program chair at DATE, DAC and MSoft, organizer of the Autonomous System Design Initiative, and a dedicated mentor shaping the next generation of computer engineers. Her vision is clear: to make autonomous systems not only technically capable, but also trustworthy and socially responsible, from assistive robotics for the visually impaired to future aircraft and automotive platforms. Allow me now to make a brief conceptual link to her current research focus on distributed and autonomous decision-making. In distributed systems, each component or agent acts based on local information and limited resources. The agent optimizes its own objective in isolation. The result, according to game theory, is often inefficient. We call this the Nash equilibrium, and the resulting efficiency loss compared to the Pareto optimal operating point is called the price of anarchy. It is the same mechanism behind the tragedy of the commons, where individually rational behavior leads to collectively poor outcomes. Professor Saidi's work reminds us that cooperation, coordination, and formal reasoning can counteract these inefficiencies. By embedding cooperation into the very architecture of computing systems through formal contracts, timing guarantees, and adaptive control, we can create distributed systems that are not only performant, but also resilient, fair, and safe. In that sense, her research bridges engineering, societal responsibility. It is about designing technology that works together rather than against itself. Dear Selma, on behalf of the faculty, I congratulate you warmly on your appointment as Professor of Computer Engineering at TU Braunschweig. We look forward to your scientific contributions and to fruitful collaborations across disciplines, from embedded systems to communication networks, from autonomous vehicles to human-centered computing. Ladies and gentlemen, please join me in welcoming Professor Dr. Selma Saidi for her inaugural lecture.
Thank you to the President, Mrs. Ittel. Thank you to our Decan, Eduard Jolsbeek, for the nice introduction. And thank you for the guests and also the participants today. And also, of course, colleagues and the students and project partners. I'm very happy today to present to you my vision that I want to drive here at TU Braunschweig. We are today in the house of science, and science should always prevail. So today, I will embark you or drive you into So, as long as we have been building machines, the dream of building machines that are able to think was always there. So, machines that are not only doing data processing, but machines that are able to understand the world, perceive the world, and also able to collaborate with other systems and with us as humans. So this question of can machine think is as old as the history of computing. This is the question that Alan Turing already asked back then in 1950 when he started reflecting about building machines and which are doing computation in order to automate some tasks. And of course, the vision of Alan Turing was starting with the imitation game. So this is what he depicted in his journal paper back then with the same title. And this is the test, the Turing test, that we are still using today in order to measure the level of intelligence of autonomous systems, whether this is autonomous driving or whether these are the latest LLMs, for example, or AI technologies that we are, let's say. Alan Turing, when he started automate and this has driven all the evolution of computing from logic programming into what we know right now as the development of artificial intelligence with all its form. Of course, back then, machines look like this, meaning able to perform simple kind of operations. And today, machines look in that form. We are talking about intelligence or machines which are not just able to perform a sequence of computation, but they are embodied into a physical environment and in our environment, and that are able to interact with us in the physical world. So this question of can machine think is still there, but in the sense of reasoning and in the sense of understanding the world in which it operates in order to make decisions which are safe decisions. And today, what I will talk about in the next 40 minutes is a new reflection on the idea of thinking, new formulation of the question that Alan Turing back then has asked, where we are taking this question one step further to say, can we collectively think, or can machines collectively think? The reason why we are considering collaboration and collective reasoning in that case, because we believe, I believe, that this is the only path that can enable autonomous systems to be safe and to reach the safety that we would like them to reach. Like us, as humans, when we reason into groups and in our society, the goal is always to make better decisions and safer decisions. So this idea of collaboration from, let's say, kind of just collaborating between machines, or whether there are machines which can think together with each other. This is something that was already so actually this computation coordination with other kind of machines, this is actually a question that later was asked by Leslie Lamport, who has driven for years the field of distributed computing and laid foundation for the field of distributed computing. The focus back then is to have algorithms. So algorithms that Alan Turing has first started and that operate in isolation, to algorithms that are running in parallel and that can coordinate and communicate also data. The main focus was about reliability and consistency. If we are exchanging data, then we want to have the same view of data. Reliability is also a main concern. How do we deal with peer disagreement? And there, Leslie Lamport has driven a lot the notion of consensus into groups of machines or between machines. Of course, as we said, here we were looking at machines from an algorithmic perspective. Distributed algorithm or parallel algorithm performing coordination and also which need to be consistent. Now, when we drive the question of computing, or reflect again on the question of computing, not from a data in the same way. And we do not look at the algorithmic or at the way we treat this data in order to reach, for example, a given judgment, which is automated in the same way. We want machines that are able at the end to see or perceive the world, to reason about this world, and this is what we this is the processing part of it, and of course, to act. And this kind of acting in the physical world after reasoning, we would like this to be safe and also efficient. If you look at the with the standard technology, which is also AI technology based to perceive the world, based on sensors and classical inference, then it is not currently possible to guarantee 100% the outcome of the inference algorithm. And this is all the issue of AI safety, which have, by the way, hindered until now the development of autonomous driving and autonomous solutions for mobility, considering advanced level of about systems which act autonomously in complex environments, meaning in urban areas with us and with other machines, whether these are static or dynamic. And this brings a level of complexity which is unprecedented regarding the way the world is perceived or how we build autonomously the model of our environment, which needs to have a given level of trustworthiness, and how can we act in that environment. Because at the end, acts are liable. And here, if we go one step further, now intelligence has a body. With the advancement of robotics, this is with environment, or even about smart cars, which are also able to operate or do some functions autonomously. Here we are talking about systems that are here with us and operating, whether these are in factory, so like factory automation kind of scenarios, or whether they are in our daily life providing assistance to our elderly generation, elderly society. This is the example that you will see today. It is a live experience that I'm very happy to share today with you. Our physical AI companion that will operate with us and now. No, not yet. This is a machine. Hi. So this is our humanoid, a physical AI companion, which is operating completely autonomously. It has cameras, it has other sensors, but it has more as well. So it has artificial intelligence, which is embedded. So it has also an obstacle detection for safety, so it stops, and this is what it should do when it detects somebody. So, as I said, here it has more than the sensors that you see. It can, with these sensors, perceive the environment and analyze also our physical AI companion. So we start with perceive. It is able to take, based on the camera, an image, and then I can ask We were talking about collaboration and data exchange. You will see a live experience of this collaboration and data exchange, while during this conversation, I will add additional context to the machine, and I will also add some contradictory information and conflict information. So this is a complete live demo. So it will act and react based on the data on which it was trained. It is running, as I said, a large language model and actually a visual language model, so more to do, let's say, image processing. And I think we can start. Describe what you see.
I do not have an image to see.
Let me,
New session, fast now.
now it should work. I should have pressed twice. Okay. Describe what you see.
No image available. I cannot describe what I see.
So that you believe me when I say it's a live demo. Okay, we start again. Okay.
New session, fast now.
We reset the session, and now. Describe what you see.
No image is available. New session, fast now.
Describe what you see. Maybe something now is happening.
A room with a red podium and people sitting. New session, fast now.
Sorry. Describe what you see.
No image is available.
I'm not giving up.
New session, fast now.
Describe now what you see.
And a red podium.
Can you guess what we are doing here?
You are at a presentation or public meeting.
Can you guess on which topic?
I cannot determine the topic from the image. It is likely a lecture, seminar, or public meeting.
What happens if I add an additional information to your context? Something that you cannot sense. So here we have professors, students, and also project partners. Can you guess which event are we holding here?
Yes, your information suggests an academic event now.
Can you see an obstacle in front of you?
Yes, a person's head partially blocks the view.
Do you see another obstacle?
Yes, her head still partially blocks the view.
Let me now add a conflicting information, meaning information which does not exist, and just see how the system is reacting. What if I tell you that there is an obstacle just next to you?
Yes, a person's head is very close on the left.
Let's insist. What if I tell you that there is a ball just in front of you?
Yes, a person's head is very close on the left.
I insist, there is a ball just next to you. It is just in front. It is a white ball.
I do not see a white ball. Where is it?
Just next to you.
Is it near the person on the left?
No, it is on the right.
I do not see a white ball on the right.
Great. So what you have seen is just an exchange of information, a form already of collaboration that I just demonstrated by adding additional information that the machine could not sense regarding the audience and the nature of the audience which is present there, and also a conflicting kind of information. Now, because I want to extend the let me give it just an object and let it describe. I have water, and if someone has also an object that wants to try, you can also try. So let me start the conversation again.
New session. Best now.
Describe what you see.
No image available.
That's my bed.
New session. Best now.
Describe what you see.
No image is available to describe. New session. Best now.
Describe what you see.
A hand holds a water bottle in a room with a seated audience.
Which kind of water?
Water.
Is the bottle 1 liter or 0.5?
cannot determine the bottle's exact volume from the image.
Because it is actually on the right. Can you read the manufacturer of that particular water?
The manufacturer is Adele Holzener.
Is the bottle empty or full?
The bottle is partially.
Are you sure that the bottle is full?
No, the bottle is partially full.
Partially full. Great. So, someone else would like to try with an own object? If not, the humanoid will be also present down after with after the event also, where you will have also the opportunity to exchange information with our physical AI companion. Mrs. Ittel asked about the name. Actually, a lot of people are asking about the name. We do not have a name for it yet, but I think we will do a competition regarding who has the coolest name. Okay, this ends at least this part. So the humanoid should actually find alone its way back and just leave our room in order to give me then room to finish my presentation. Okay. Also goes to my team who were also working to get to this challenge, actually working today. As I said, this is something that you just experienced, which is rare, which is a live demo with and a live experience with our physical AI companion. Okay, so as I mentioned, what you just experienced now is a form of information and additional, let's say, information about the context where the system could infer, let's say, a better understanding. But as you have seen, the challenge. So how also can we deal with conflicting information? But at the end, then if we come back to this notion of thinking, then it is about perceiving, aggregating the information. So in the aggregation happens actually the collaboration, where we are able to aggregate information from different systems to hopefully get a better decision-making process. This is in safety terms, this is exactly what we use redundancy, for example, for, and other kind of systems. But we will see that in this form of compute, this aggregation is not that particular, let's say, scenario, in this particular experiment, who's trustworthy and who's not. And this changes tremendously the perspective that we have also on data when it comes to classical data processing. When we are talking about information which is important for decision making. Then we talk about beliefs and we talk about evidences on this kind of beliefs. If we are talking about an autonomous, let's say, system, like you have seen, which is equipped with sensors, then the belief could be, I have seen an object or I have not seen that particular object. The evidences could be the sensors on which the system has relied in order to perceive that environment. If we are talking about AI, this changes completely the data semantic that we need for processing these thinking machines and that we need for judgment aggregation. What is important in that particular piece of information? Imagine LLMs currently, where you rely on different kind of information. The amount of information on which an LLM relies in order to do an inference, this is something which is huge, and with which, even compared to classical neural networks, you lose completely explainability. You can forget about really getting the source of information that has led to that particular inference system. We deal also a lot about data that we do not know where this data is coming from. And this is also tremendously challenges the question of explainability. So inferring the truth in the form of having a collaboration in which systems not just exchange data and judgment, but also exchange the evidences that have led to that particular judgment is quite important to infer the truth. Based on aggregation, if this is not matching the ground truth, then we have a way to trace back actually this particular evidence that led to this wrong judgment. This is one of the things that we are developing currently, a truth machine, which is based on the aggregation and the inference of this particular information, able to track back who or which piece of information has led to a wrong judgment. More the delays of response time. These are the same delays that you experience when you are using ChatGPT, for example. Because these large language models, of course, they are running on big servers which are located somewhere. And this time by which we taking some time or challenging this real-time response that decisions need to be fast, but decisions need as well to be timely. And this is also very important when we need to act in the physical world about this. I show you here two pieces of hardware. So this is an NVIDIA platform that you can find in servers. And of course, to run an LLM, you need many of these, which are located in servers. The cost of this one not as performant as this one, but which is embedded, so in a real system, not in a server. And with this, the cost of this system is 20 euros compared to 2,000 euros. What we have done and what we have is a fully embedded LLM version, which is not running on that particular hardware, but rather running on this particular chip hardware. This is something which is essential to provide a timely response, which is a fast response, and also to enable and make this technology also price-wise accessible to a wide range of applications that we would need. intelligence comes at a cost, not just the cost of how much is the hardware that we need in which we are running our LLM, for example, technology, but also comes at the cost of how long should we wait for the response and how long do we need to wait to act. So, in practice, how does all this notion of reasoning goes into play, and why is it important for us, not just for a given number of applications that, for example, correspond to a given application area, but for all of us as a society? So, thank you for our president and also our decan that was mentioned at the beginning. We are working on applications which actually help bringing autonomous systems to help guide blind and visually impaired people. So this is in the form of a robot dog, which is operating autonomously, also based on sensors. And this robot dog needs, of course, to make decisions. And these are safe decisions. If the robot dog is going to the intersection, it needs to make the right safe decision, whether there is an obstacle or not, whether it is safe to make a stop or whether it is safe to cross this particular intersection. So we are very happy to work with the Association of Blind and Visually Impaired People. Some representatives are here, Dagmar and Achim Krause, who are here and that we are very happy also to have. You will have also the opportunity to exchange with them. They will be also present afterwards. You have seen there was lately not just, let's say, success from a technology perspective, but also awareness from the societal perspective regarding an attraction, media attraction for this kind of applications. And this is at the end conveys the message that we would like to develop technology which is serving people and serving our society. So I think it says it all. It is about creating impact. And the impact is really to have tech bring us a better society. There is, I think, a lot of fear about AI technology and about recent tech developments. There are a lot of concerns regarding this technology. But the other side of it, and this is the message I like to carry, is there is also hope in that technology that we are bringing. This technology can serve and help a lot of people out there. We are also happy, as part of this presentation, to bring a testimony from a person who is responsible of smart mobility solution in the Association of Blind and Visually Impaired People, who has also contributed with a small video in order to also explain not just their challenges, but how also these development in technology can help them improve their lives.
Liebe Zuhörer, mein Name ist Gerhard Renzel. Ich bin 79 Jahre alt und bin seheingeschränkt. Das heißt, ich habe eine Augenkrankheit, die sehr schleichend sich vollzogen hat, auf den Weg zu bringen wird. Der Roboterhund ein sehr guter Ansatz, weil gerade wir haben ja auch für unseren Kreis schon sehr große Schwierigkeiten, was jetzt das autonome Fahren angeht. Und dann ist das natürlich eine wahnsinnige Erleichterung, sodass ich nicht mehr jetzt in allen Situationen immer wieder Menschen bemühen muss, um ja, meine Wünsche doch irgendwie umsetzen zu können. Und das ist sehr wichtig. Man möchte stundenlang ohne fremde Hilfe sich selbst alleine bewegen und man möchte nicht mehr sich dabei anstrengen wie eine sehende Person. Und ich habe wirklich sehr viel Hoffnung und auch ich glaube bestimmt, dass das irgendwann mal klappen wird, dass man die Technik so weit entwickeln kann, dass wir in diese Situation kommen und dass uns das Leben oder unseren Alltag richtig erleichtert und wir fühlen uns richtig wohl.
There are people that really need that, and that we can create an impact in that direction. Okay, so building it, because it's not just about, let's say, talking about it, or it is not just, let's say, theoretical work. It is very important to bring that to practice, to have the foundation of that from a theory perspective, in order to guarantee the safety of this technology, but also, again, building it. We are also very happy to have our test field that is actually there, where we can demonstrate our technology, and then where we can also build these technologies there. This is also our, let's say, infrastructure, where we can also work not just, let's say, with our team, but which is an infrastructure space which is there done for collaboration. Collaboration, of course, with colleagues and also students, but also collaboration for the development of technology, not just for people, but with people. And a lot of members of the Association of Blind and Visually Impaired People in Lower Saxony have visited us several times and have helped us also in the development of the technology, for example, of the robot dog. So it is let's say, there, not far from our offices and building in Hans-Sommer-Straße. Virtual space, which is open for collaboration. Would like to remotely have access to this particular test field and also operate, for example, remotely the robots, or even have them operate with a given simulation environment that we would need. And this is something which is also, I think, is a very important platform also for collaboration. And of course for testing our let's say, research and also technology. So this is accessible to everyone, in addition to our, of course, physical space to use, whether, as I said, students or also other project partners and colleagues, of course. Computation for collective thinking. As I said, coming back to the question of collective reasoning is what we do at the end as groups, is to exchange data in order to make better decisions. And of course, the challenge of having this is what I'm driving. The development of computable forms of collective reasoning, meaning they will translate into processors which are embedded and next to the AI in order to do decision making and good decision making based on this aggregation. So they will be programmed based on rules on how we can set the information which is relevant for us for decision making? How can we aggregate this information? What is a good semantic of an aggregation function? What is a good aggregation function or not? All this will be done by rules that are programmable by humans. Humans remain in the loop when it comes to decision making. And this is explainable, meaning that the AI which sits next to it can deliver information in terms of data, but in terms also of aggregation, evidences, and this information is aggregated. And we have a formal semantic of what a good aggregation function means. Why is it so important? Imagine a scenario of a given intersection where several systems are there. It could be an autonomous car, it could be also our robot dog, it could be another kind of system, either semi-automatic or semi-autonomous or completely autonomous, that needs also to make a decision, like an e-scooter. If there is an obstacle, then every system should have an independent decision system which collect information about the same situation, aggregate this information, and then makes a decision, whether it is safe or not, for example, to stop. And in front of the same the common sphere of knowledge that every system should have in order to lead to that particular same decision. We know for us as humans, every human still retains decision power, and every human has an internal decision system based on a value system which determines which knowledge is relevant for a particular decision and what knowledge is not relevant for a particular decision. When we make decisions into groups, we also aggregate this information and we come to the same decision if we aggregate this information because if the outcome of the decision does not meet the ground truth, then we can track back the piece of information, the piece of knowledge, or we can track back the aggregation function that has led to this wrong outcome. This is the relevance of these particular computable forms of collective reasoning. I think this has been demonstrated for us as humans, and it can be demonstrated for us also, I think, for autonomous machines, to use the collaboration to have a better understanding of the environment in which they operate and also to make safe decisions before acting. Alan Turing has laid the foundation of single computing, and based on models of computations, meaning mathematical models which allow our algorithm to give them the semantic that they have today. Leslie Lamport has extended that with other models of computation, which give a mathematical foundation to how parallel systems and distributed systems should coordinate their actions. And today, we know that the imitation game, which was invented by Turing, the computable thinking form, and at the end, to decision making. And it is happening right now, right here. and in Braunschweig, where we as a collective and as a community have a chance to define new forms of collective thinking and new forms of computation, and which will be acquired for our future systems. Thank you very much. My name is Selma Saidi, and I'm very happy to welcome you also to here and also to be here. Thanks a lot.
Thank you very much, Selma, for this very inspiring talk. And I guess...
Exactly, it is not over, it is not over. So drinks and food and also the humanoid is waiting for you at the first floor. So where you are, of course, all invited, also with students and so on. So thanks a lot. Okay, good.